Alright guys, sorry about that. My computer has a virus, and so the tech guy was here to help me fix the virus or delete the virus or do something with that. Anyway, at this point in my life, I do not know how to edit videos so that way they combine to one. So I'm just gonna, this is the second video, but we're gonna pick up where we left off, okay? Alright, so we ended on step 3. We said since x cannot be 0, there's no y-intercept. So under y-intercept, we're going to write none. The next step in the directions, let me pull that out right here. The next one said locate the vertical asymptote. Okay, so we're going to do, I'm going to use this side. We're going to use this, and we're going to say on, back. Okay. So step 4, try to be neat on your notes so you can follow. Step 4 said, hey, find the vertical asymptotes, okay, or tote if there's only one. I'm going to use step 2 here since it's already a factor for me. Vertical asymptote, we are going to take the denominator and we're going to set it equal to 0. Since there's only one value in the denominator, we are just going to take it and set it equal to 0. And since I don't have to do anything, that is my only vertical asymptote. Step 5. Let's look at step 5 really quickly. Step 5. Locate the horizontal or oblique asymptotes. Determine points, if any, at which the graph of R intersects these asymptotes. Okay, so it's a little bit more involved. Remember, we can never cross over with your VA, so that's why in step 4 it doesn't say find the point if it crosses. But on step 5, not only that we need to find OA or HA, we have to say, hey, does it cross or not? So step 5, let's decide, is it an OA or is it an HA? Okay, is the degree on the top bigger than the degree on the bottom? If it is, then it's an improper, and if it's an improper, then it's going to be an OA. And I'm just going to write OA y equals, and we'll box that up right there. I'm going to show all my work right here. Okay, x goes outside, x squared plus 3x plus 2 goes inside. X squared divided by x is x. Multiply it back. Don't forget to change your sign. X times x is positive x squared, but change my sign to negative x squared. I'm going to cancel. Okay, so that will give me 0. Bring down my 3x. 3x divided by x is going to be a 3. 3 times x is 3x. Change my sign to negative 3x. That's also going to be 0. Bring down my positive 2. 2 divided by x, that's not possible, so this is going to be my remainder. So my remainder is 2 over my divisor, which is x. Remember, the limit as x approaches infinity, this goes to 0. Okay, so x gets really, really, really large, like 1,000. 2 divided by 1,000 is so small, this is insignificant, so we don't need to worry about this. So my oblique is this, x plus 3. So y equals is required. X plus 3 is the equation of this line. We'll box that up. Now we need to see, okay, determine points, if any, at which the graph of R intersect this asymptote or not. So let's write below here. Intersect question mark is still the same piece, okay? So how do we determine? We know that y equals 2x plus 3, okay? We have this equation as well. These two are the same, keep in mind, okay? These two are the same. R of x equals x to the second plus 3x plus 2 all over x. Well, R of x is the same as y. So what we do is we take this y and we substitute for that y, okay? If they are in fact, okay, equal, then they have an x value that we can use. So here we go. Take your oblique, which is x plus 3, set it equals to, this is y equals, this is y equals. They are both y equals, so we can substitute them. So we're going to go x squared plus 3x plus 2 all over x, okay? So now I'm going to try to get rid of fractions by multiplying both sides by x. Those two will cancel each other out, so that and that will cancel. We have now x squared plus 3x equals to the right-hand side, x squared plus 3x plus 2. Okay, so do you think these two are, can I solve for x? Is there an x value that would make them equal? Okay, so let's think about it a little bit more. I have x squared on both sides, so I can cancel. I have 3x on both sides, I can cancel. So on the left-hand side, I have 0. On the right, I have 2. Is that okay to have? Okay. Since this is not equivalent, okay, it does not intersect. So we're going to say, determine points, if any, at which the graph of R intersects these asymptotes. So not equivalent, so I'm going to say R of X will not intersect OA. Okay. So that's going to be my second answer of step 5, still in step 5. Okay. Then step number 6, it says graph R using a graphing utility. So let's bust out your calculator. I'm going to wait for you. So go ahead and go find your calculator. Hit pause if you need to. Okay, here's my old school calculator. Okay. All right, looks like, look at this page. I have a lot of things going on. All right, so another thing I'm going to move is this. We're going to move all of this to another page. Another page. I don't move this too, okay? Another page. I'm just going to use all of this. So I'm trying to be as neat and organized as I can. 1, 2, step 3, step 4, okay? And step 5, so now I'm on step 6. I'm going to do it right here. Step 6, graph by calculator. Okay. So enter in your equation. Here we go. Y equals. On the numerator, I have 3 terms. I have x squared plus 3x plus 2. Close that up. Divided by x. I'm going to want a window. Okay, so let's do negative 10 to 10. And zoom fit to see what happens. Anytime if there's a calculator question, I'm going to ask you to give me the window. Okay, so window, x min, negative 10. Zoom in so you can see. Here you go. X max, positive 10. Let's check out what zoom fit gave me. Zoom fit gave me negative 7.2 and 13.2. That's kind of an odd number. So I'm going to go down and fix it from negative 13 to positive 13. Okay, there. So Y min, negative 13. Y max, positive 13. All right. Now, do you have to have the same windows as I currently have? No, as long as you can see everything that I see here. So we graphed it using the calculator. And then it says here, step 7, use the results obtained in steps 1 to 6 to graph R by hand. Okay. So now, because I'm going to sketch this on step 7 anyway, what I need from you is to just do the window only using the graphing calculator. On your test, you're not going to have a calculator. Okay. So make sure you understand how to do it. Okay, graph using a calculator, but only write the window. Okay, we'll save the actual graph for step 7. So here we go. Let's do step 7. Where should I put step 7? Right here. Step 7. Graph by hand. It said so. Graph by hand. So let's draw our coordinate plane. I'm looking for a straight edge. We said y was 13 by 13, x was 10 by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? I know we said 13 on the y, but that's okay. as long as I have enough tick mark to cover steps 1 to 5. Okay, so step 1. Let's look at what we obtained on step 1. Step 1, we said the domain can never ever be 0. So we know that there's nothing. Nothing should be on 0. Step 2, we need to reduce it. We don't need it to graph. Step 3, x-intercept. Definitely. I'm going to plot in negative 2 comma 0. Here's negative 2 comma 0. Here's negative 1 comma 0. That looks like a comma. That's a big comma. Okay. So negative 2 comma 0 and negative 1 comma 0. Okay, so those are them. Then that's step number 3. Step number 4, can we use information from step 4 to graph? Definitely. X is at 0. That's my VA. So if you want me to see there's a VA on the y-axis, just go slightly to the right and draw your dashed line and label it at the bottom or the top what this is. Okay. So notice how I'm using really slow dash line. So I have a VA x equals 0. So far, we're up to step 4. Step 5, I have an oblique, and my function would not intersect my oblique. So I'm okay to just graph it out normally. The y-intercept's at 3. So go up 3. 1, 2, 3. The slope is positive 1. So positive 1, right 1, positive 1, right 1. I could either go down 1, left 1, down 1, left, down 1, left 1, down 1, left 1. I want you to make enough dots so where you can make a nice straight line. All right? So this is my oblique with a y-intercept at 3 and a slope of 1. Okay? Y equals x plus 3. So far, we got all the steps in. Then, all you have to do in sketching by hand, okay, is this. Even without the graphing calculator, most likely you are not going to have a graphing calculator for this step, okay? So on your test, you would not have a calculator. You would just have steps 1 all the way to step 5, okay? So on step, notice how I'm going to have 2 curves, okay? Let me spell this out for you. Make it a red pen. I still have 1 VA, okay? 1 VA means 2 curves. Okay, that's what it means still. It doesn't change. 1 on the right, 1 on the left. If you don't have a calculator, okay, in the case where you don't have a calculator, so what if we do not have a calculator? Okay, then you would find out this way. This is the way that I would like for you to graph it without a calculator. I want you to draw a number line. Yep, just a simple number line. Okay. I want you to draw a number line and I want you to put all the critical points. Okay, all the critical points on here. So the critical points, okay, draw a number line and use critical points. That means only x values is needed. So what steps were x value found, whether it's a VA or x-intercept, right? So we found some x-intercept right here at negative 2. And it doesn't have to be in order in any shape or form. And then we found another x value of negative 1. And over here, we found an x value, which is a VA at 0. So we're going to put those in there. Okay, those are the only 3 places that has critical points of x values. So from here, what we're going to do is going to test these regions, okay? So let's look. I'm going to test something over here. Okay, I'm going to test something over here. At negative 2, we know it's on the graph. Okay, so these are on it. At 0, we know it's an asymptote, so we can't even have it. So the question is, if I pick something, anything at all, on the left-hand side, like negative 100. So pick negative 100. Is it going to give me a positive y value or negative y value? Okay, so here we go. Negative 100 square. Positive or negative? positive, a really large positive, okay? Then what happens when I have this? What happens when I have these? Doesn't matter, okay? So negative 100 squared is a positive 100, a large one, divided by a negative 100. Would you agree that this output is going to give me a negative number? If you agree, then I'm going to write negative right here. Okay? We're just looking for positive or negative output, and that is it. I don't need to know the exact answer. Okay? I'm going to pick something in between, which is negative 1.5. So here we go. Negative 1.5. I can use the original or I can use the lowest term. Since the lowest term is just a factor term, form, then I can use this one. Okay, here we go. Negative 1.5 plus 2. Is that positive or negative? That would be a positive. Multiply. Negative 1.5 plus 1. Is that positive or negative? That is negative. Divided by negative 1.5. That is negative. Positive times a negative is a negative. A negative divided by negative is going to create a positive. Okay? So that output in between these two x-intercepts is now positive. Now I'm going to do the same thing. Pick a value in between negative 1 and 0 and test it out. Let's pick negative 0.5. All right, here we go. This is all gone. Negative 0.5 plus 2. Is that positive or negative? Positive, right? Okay, times negative 0.5 plus 1. That's also positive. Divided by negative 0.5. That's negative. So net positive times a positive is positive. Divided by negative, that's going to give me negative. So in between negative 1 and 0 is negative. So now I only need to worry about one more testing region or interval. I'm going to pick positive 1,000. I can pick whatever I want. Keep in mind that as long as it's on the right-hand side of this. So when the input is a positive 1,000, here we go. Positive 1,000 plus 2 is positive, times positive 1,000 plus 1 is another positive number, divided by positive. So the output is positive. Okay, so check this out. What if I don't have a calculator? Then this is what you need to do. So let's check it out. On the right-hand side, see this is right-hand side? On the right-hand side, okay? When x is a super large number, when x is a super large number, output is positive, okay? That means it goes here. And I don't need you to use dots. Remember, the definition of asymptotes is that the curves approaches. In this case, we tested it and it's not going to cross over this at all. So right now, we're not going to touch it. Okay, so because on the right-hand side of 0, this is your VA, which is 0, the output is always positive. Okay, and let's look at this piece. Okay, on the left-hand side of negative 2, remember here's negative 2, the output is always going to be negative. So it goes right there. In between negative 2 and negative 1, look, the output is positive. So I got to go up a hump. It has to be positive. There has to be a hump right there. Okay? And then from negative 1 to 0, everything has to be negative. So see how this is fitting in with this? Now let's look at my calculator. With our negative ides, can you guys see that there's a hump right there at all? Okay, which you can't see. Oh, can you? All right, so check this out. If you were just to sketch this out without doing this number line, you would have missed that there's a little hump above the x-axis right there. Okay, so without a calculator, it's even better, as you can tell. So that's how we do it. Okay, so on your homework, if it said to use a calculator, then just use a calculator just to give me the window so I know you know how to use it. But on the test, you're not going to have one. So learn this method right here. All right, that concludes our notes for today. Have a wonderful day.